In this video, I'm going to review the more traditional method for determining the electron configuration. I'm going to use the same example. It's going to be rhenium, Re, which has an atomic number of 75. And that is located here. Note that rhenium is in the D block. It's in the period that corresponds to a 5D terminal subshell. And it is in the column that would indicate that it has a 5D5 terminal subshell configuration. So I'll just write down here 5D5 is the terminal subshell configuration. And for the traditional method, the first step is the same as the reading left to right method. So the first step is to label the periodic table, which I've already done here. Label the periodic table. So I already have my 1s down to my 7s, and then I have my 2p down to my 7p, 3d down to 6d, and then, oops, I forgot my F subshells, but I'll go ahead and I'll label those now. So it's going to be 4f over here for cerium, and then 5f over here for thorium. The second step is the same. Locate the element and determine the terminal subshell configuration, which we've already done. And of course, for rhenium, it's going to be 5D5. And the third step is to draw the filling diagram. And the filling diagram is drawn like this. So let me find a spot where I can draw it. Move this down here. In the filling diagram, you just write, starting with 1s, just do 1s, 2s, 3s, 4s, 5s, 6s, 7s, and then in another straight column, 2p, 3p, 4p, 5p, 6p, 7p, and other column, 3d down to 7d, 4d, 5d, 6d, 7d, and then 4f, 5f, 6f, and then 7f. Then you just draw diagonal arrows that intersect all of the S subshells. So over here, let me do this, and I'll make this slightly transparent so we can still see the subshells. So it goes through 1s, and then parallel line through the 2s, parallel line through the 2p, and then 3s, and then through 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, and 5f, 6d, and 7p. Notice when we reach the 7p, we pretty much filled out the entire periodic table, or all the elements up to oganesson, but we can draw the diagonals here anyways. All right, this is our filling diagram, and it tells us the order in which the electrons fill. And briefly, it just shows that, one, we start reading here, so start here, and then just end wherever your terminal subshell is. And so the 1s is the first one to fill, 2s is the second, and then it goes 2p, 3s, 3p, and then 4s. This is where it gets funny. It goes 3p to 4s, and then it goes to 3d. So 3d subshell is the fifth subshell to fill, and then it goes 4p, 5s, 4d, 5p, 6s. So just to review, the first subshell to fill is the 1s, and then the 2s, and then back up. Goes 2p, 3s, back up, 3p, 4s, back up, 3d, 4p, 5s, back up, 4d, 5p, 6s, all the way down until you reach the subshell for the element under consideration. In our case, it's going to be rhenium. And recall that rhenium has a terminal subshell configuration of 5D5. And so we're going to go here and we just find 5D. And we're going to fill all subshells that come before 5D. And then when we get to 5D, we're just going to do 5D5. And now we don't even really need the periodic table anymore once we figured out the terminal subshell configuration. So I'm going to go ahead and I'm just going to fill this and increase the gauge on my pen for a moment. And here, just going to start. So I start 1s2, 2s2, 2p6. So I've got 1s2, then 2s2, 2p6, 3s2, 3p6, or 3s, 3s2. I forgot my 3s2. And then 3p6, 4s2, then 3d10, 4p6, 5s2, so 3d10, 4p6, 5s2, 4d10, 5p6, 6s2, so it goes 4d10, 5p6, 6s2, and then I get to 4f14. And then finally, I end at 5d5. So let me make this a little neater. 4f14. And 5d. This is the full electron configuration for rhenium. Determining the abbreviated electron configuration is the same. I just go one column up, or sorry, no, one row up. I go one period up, and then I extrapolate all the way to the right. And I see that xenon is the noble gas that comes before rhenium. And so I go into my electron configuration. I find here the last filled p subshell is 5p. And so everything here is going to correspond to the electron configuration for xenon. And then everything else that comes after it is just going to be the same. It's going to be 6s2, 4f14, and 5d5. That's it.